Welcome to CW 2.1. Today we're going to start talking about domain. So right here, finding the domain of a rational function. So when you're thinking about domain, I really want you to focus on this. Think about what x can't be. And that will help us figure out what x can be. So for example, you have a fraction. You really want to focus on the denominator of a fraction. Because if you think about a fraction, again, think about what can't happen. You can't have a 0 on the bottom, right? So this bottom part cannot equal 0, which means x can't be negative 5, because that would make the bottom 0. So the way you write this is called set notation. Put a squiggly bracket, x, a vertical line like that, and then you write this. Now this might look really complicated, so I'm going to explain mathematically what we just did. This bracket here and here is just stating a set of numbers. Could be like any number. This is the important part. This is like saying all x. So if this is like a computer program, what you're saying is like we're starting with all the numbers. So this is say consider all numbers in the world. This vertical line means such that. And this final part is simply saying x can't be negative 5. So if I had to translate this, all we're saying is that x can be everything except for negative 5. So this is our stating x can be everything. And now we're saying except for negative 5. So that's how you're going to write these out. So let's try a couple more examples. On this one, I can see this got to be factored. And now we can kind of see it. X can't be 2 and negative 2. So for our domain, we make a squiggly bracket. X such that x cannot be plus or minus 2. And we're done. That's your domain. Go to the next one. This one's pretty weird. If I try to make this equal to 0, look at what happens here. You get x squared equals negative 1. And in 2a, we would use a complex number. But in 2b, we're not going to deal with that. We're just going to say this can't happen. You cannot square root a negative number and get a real number back. Which means there is no way to make this bottom thing equal to 0. So your domain is actually all real numbers. Now, if you're in the shorthand, you can simply write this R. A few of your teachers might have taught you that earlier. That R means all real numbers. And for the last example, it's pretty straightforward here. Same thing. We can see x can't be 1. So we're going to write the domain, everything except for 1. So those four are pretty straightforward. Let's go to a harder example right here. So if you look at this bottom thing, you might recall this from 2a. This actually factors. It factors into x minus 1 at times x squared plus x plus 1. Now, if you forgot how to do that, that's okay. Just ask in class about how to factor cubes again, and we can review it if you need to. Now, the important thing to remember is that when you factor a cube, the second part, it actually can't equal 0. So you have to worry about that part. You just got to worry about this part. So all we're going to write is x can't be 1, which means the domain is pretty straightforward. It's just everything except for 1. So if you want to do like the shorthand way, it is possible to just not even do any of this. You can erase all of this right here if you wanted to. And do it by inspection, meaning just look at this and think, how do I make that equal to 0? Well, 1. That's the only way to make this 0, and that leads into that. So you could also do that and just avoid the factoring altogether. That's also a valid method. So that's part 1. Next part. Find the vertical or horizontal asymptotes for each function. Now your book is going to ask for oblique asymptotes. However, just cross those out. We're not going to cover that in Algebra 2b. You will cover that next year in pre-calculus. So hopefully all of you remember this idea of an asymptote. The most common graph you'll see it is this. Y equals 1 over x. So hopefully you recall this from our last algebra class. There are two like swooshes like that. And then you have an asymptote here and here. So put simply, it's basically a line that your graph will approach. That's the basic idea. But we're just going to start with the fundamentals. We're going to start by talking about the vertical asymptote. So we call them VA, and again, this stands for vertical asymptote. Asymptote. So we'll call them VA rules, like that. So what you want to write down is this. If f of x is simplified, your VA comes from making the denominator 0. So that's all you have to know for vertical asymptote. If it's simplified, just make the bottom 0. So take a look at this. Look at this thing. Yes, it's simplified because it can't go any further. You write VA, and it's important, right? X equals 1. Okay, so we need to have this x here because that means there's a vertical line that's your asymptote at 1. So here's 1, and then there's a vertical asymptote happening like this. Next one. VA. This should look familiar, so we'll just write x equals plus or minus 2. For part C, look at the bottom here. So we talked about this earlier, up there. This x0 plus 1 will never equal 0. So for VA, you simply write, well, there are none. Now G is a tricky one. A lot of people factor the bottom, which is good. X plus 7, x minus 3, and then they write the vertical asymptote is x equals negative 7 and 3. The problem is up here. That's why this is so important. If f of x is simplified, it must be simplified, which means if the top is factorable, you should really factor it. And look at that. The x minus 3's cancel out. So later on we'll talk about what that does, but for now you have to understand that your function must be simplified before you can consider anything, which means the only vertical asymptote is negative 7. And our last example right here. So this one, not too much we can really do here other than look at the bottom. And by the same reasoning we did over here, I can see that 1 will make the bottom 0. So we're going to write the VA is x is equal to 1. And again, there's not really any way to factor this top part, so we're not going to worry about that. There's really no way to simplify anything for something this complex. So look at that. Our VAs are done. Now the next part is going to be your horizontal asymptote, or your HA. So I write HA into all these for you. This is the more complicated part. So I'm going to show you the rules. We're going to do it, and then I'll kind of talk through what it means. So HA rules, you can take notes over here. And HA stands for horizontal asymptotes. The way this works is you're going to be given a function f of x, and it's going to be ax to the power of m plus a bunch of stuff over b x to the power of n plus a bunch of stuff. All you're going to care about is the leading term of the top and the bottom. That's the only part you care about. You're just looking at that. There are 3 things that can happen. Case 1 is that the exponents are equal, meaning m equals n. If this happens, your HA is going to be y equals a over b, meaning you take the coefficients. There's case 2, where m is less than n, meaning the bottom is greater. If that happens, your HA is y equals 0. And case 3 is that m is greater than n. If that happens, you simply write no HA. So I know right now they just feel like rules, because they are. After we do the problems, I'm going to talk through kind of what they mean. So for this one, the power here, they're both 1. So we are in case number 1. The powers are equal, so take the coefficients. 1 over 1, that's your HA. B, look at the exponents. We have x squared and x to the first. The bottom is bigger. So if the bottom is bigger, we're in this situation. Because notice how m is the top, n is the bottom. The bottom is bigger, which means you just write y equals 0. For letter C, the powers are equal. So just take the coefficients. Y equals 2, because 2 over 1. Letter D, the powers are equal again. So the coefficients are going to be 1. And this one, we can see the top is bigger, because 5 compared to 3. And that's what case 3 is going to be. The bottom is bigger, so we just simply write none. Okay, now the reason this happens is because you just think about growth. So for example, let's write y equals ax to the box over bx to the box. If you think about making it really big, let's say this is like both 100. What essentially happens is the rest of the function doesn't matter, and these get canceled out, and you're left with a over b, and that leads you to situation 1, when the exponents are the same. Now, if the exponents are a little different, let's say you have 99 on the top, 100 on the bottom. This is example 2, or case 2. What happens is, again, this is so big that the back doesn't really matter, and we can actually kind of simplify this. That becomes x to the first power, and these are just gone. And what happens is this expression is going to tend towards 0, and that's why the function should approach 0. And the last situation is going to be, well, what happens if the top is bigger? And again, what happens is these cancel, but you're left with the x on the top. So what happens is this function will keep growing and growing and growing, and there is no horizontal asymptote, which leads to this situation. Okay, now if that didn't make sense, that's okay, because the main thing in Algebra 2b is that you can apply these rules. You can always ask more questions in class.